Hello my dear viewers and my dear students. Welcome to my math distance learning session. Today, in continuation with the set theory, we are going to be doing the part 7 for the series, which is going to be on solving problems using Venn diagrams. If you have not watched my last video, which gave an introduction of Venn diagram, I will put the link in the description box, and I would advise you to please watch that video before you watch this one for better understanding. So this topic of solving problems using Venn diagram is going to be very useful for grade 9 and 10 students, and towards the end of the session today we will be covering some important questions which will help you for your examinations. Let me acquaint you with the learning objectives of today's session. In the session today, you are going to learn how to solve problems using Venn diagrams. So let's get started. Okay, so before we move on to solving the problem, let me recall and revise for you the 4 types of cases that are possible when we are having 2 sets and we are trying to draw their Venn diagram. So the first case which is possible is disjoint sets, and as you have seen in my previous videos that when it is the case of disjoint sets, the two sets, set A and set B, which are represented by the 2 circles here in the Venn diagram, and the universal set, they don't meet at all. So when they are not meeting, there is no intersection, so there is going to be no element which is going to be common, and that is why the A intersection B in the case of disjoint sets would come out to be the empty set. That is the first case. Second case, when the 2 sets are exactly equal to each other. That means A is also completely contained in B and B is also completely contained in A. In that case, because the 2 sets are equal, you will just represent the Venn diagram with one circle to represent both the sets A and B. The third case which is possible is when one set is a proper subset of the other. That means A is strictly contained in B in this Venn diagram. So the smaller circle which is contained inside the bigger circle would represent your proper subset. So this is the third case where the Venn diagram can be there. And finally, the fourth and the last case which is possible when 2 sets are intersecting. So these 2 circles A and B are meeting, and what you get in between is the common region or the elements which are in the common part. So here in this case the sets must overlap, as you can see, and the intersection is not going to be the empty set. There are going to be a lot of elements which are going to be common in both these sets, and these are the 4 cases or 4 possible situations or the Venn diagrams that are possible for 2 sets. Okay, so now that we have recalled the Venn diagrams possible, let's dive into the example 1 for today. In this question, you have to determine the sets from the given Venn diagram. So here the Venn diagram is given to you. You don't need to draw it, and you just need to use this Venn diagram to answer the question. So let's write what are going to be the set U and A. So for A part, we have to write the universal set. And I would want you to recall here that universal set is a set of all elements, which is the biggest set. So it is going to be having all the elements which are present inside this rectangle. So let's count. This is the 1 element, this is 2, 3, 4 and 5. So we can just write our universal set in roster form or in list method to be having these 5 elements separated by comma. So 1, 2, 3, 4, 5, it has 5 elements. Now it's quite easy to look at the Venn diagram and just say that there are 2 elements inside the circle, so they are going to represent your set A of 2 elements. The third part says the set of elements in U that are not in A. If I may write it in the set notation, then this part is asking U not A, which is same as A complement by definition. In this part you need to give what is A complement. So we take the first and the biggest set U, and from there we subtract A. So there are 5 elements here, there are 2 elements here. So definitely when we are going to subtract, we will be just left with the remaining 3 elements. So this one goes with this one goes with this one, and you are left with these three. So that is your A complement having 3 elements. So this was an easy example to begin with, where you were given the Venn diagram and looking at it, you had to answer the question. Okay, let us take another example. Here again, the Venn diagram is given to you and you need to answer the questions that follow. So the first and second part will be quite easy for you, where you have to just write all the elements for the universal set. So all the elements which you see here, 1, 2, 3, 4, 5, 6 and 7. So A, B, C, D, E, F, G. These 7 elements will be in the universal set in the whole rectangle. Let's do the B part, where you have to write only elements of B. So as you can see from the Venn diagram, it will be D and E. Then you need to write the set of elements in A but not in B. That means which are there in A but not in B. So we can just point out these 3 and they will be A, B and C. Finally, the set of elements in U that are not in B. So we may write this as U minus B, or again we may just write B complement. So you remove D and E from the universal set, and what you get are the remaining 5 elements A, C, F and G. Last and E part is the set of elements in both A and B, and that is very easy. This is calling the value of A intersection B, which is the common element, so that you can very well see from the Venn diagram is just one, that is B. So in this way we have used the Venn diagram to answer the set question. Next example is going to be on the set complement. So here you are given the universal set. Let's count the element. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are going to be 9 elements, and you can just see that from here also. So these are 4 and these are 5. So total you have 9 elements in the universal set, and you also have another set A having 4 elements given to you. What you need to do is to find A complement. So by definition, your A complement is the set of all elements of U that are not in A, or if you may write, then this is the notation. A complement is U minus A. That means from the set of U having 9 elements, you're going to remove the 4 elements of A. So I remove these 4 and we are just left with the outside part, which is outside the circle. So it will have these remaining 5 members. So we can now write our A complement as this value. So it has 5 elements, and both ways you can look at the Venn diagram and say, or you may just do the set subtraction also. Both are going to be correct. Okay, so let's see now the next question. This is a question on just set operation. So you can do it without the Venn diagram also. If you feel more comfortable in Venn diagram, then you may draw the Venn diagram and also do it. So all 3 sets are very clearly given to you: the universal set, set A and set B. So this has 10 elements. You can count and write 4 elements and again 4 elements. So in part A of the question, you need to give A union B complement. So we are going to do this stepwise. Let's write A union B first. So how do we write A union B? So A union B means the elements which are there in both the sets, and we don't repeat the ones which are common. So first let's highlight a little bit here. What are the common? So 3 is common. Let me change colors. 7 is also common. Remaining other elements are not at all common. So 1, 8, 9 and 10 will come only one time because they are not repeating, and then 3 and 4 can just come once. So overall there are now 6 elements which are there in the union. Okay, now we need to take complement. So by definition this will be U minus A union B. So you're going to use set subtraction. From the universal set having 10 elements, you're going to subtract these 6 elements. So definitely you will be left with the remaining 4. So just remove these and you will get 2, 4, 5 and 6 as your answer for A part. Okay, so I hope this was quite useful and easy for you. Let's move on to the B part. Here we have to take the operation of intersection, and before that we are taking the complements. So let's do this again stepwise, and we will first find A complement and B complement and then take the intersection. So A has 1, 2, 3, 4, 4 elements. So A complement will have 10 minus 4, that is 6 elements. So just do the set subtraction, you will get your A complement. Similarly, for B complement, it will be 10 minus 4 and it will be written in this way. So you have again 6 elements here as well. Now you have got your A complement, B complement, just take the intersection. And when it is intersection, we have to take the common elements. So let's see what are the common elements in these two sets, and we are going to just write our final answer there. So 2 I can very well see is common, 4 is also common, then 5 also is common, moving on, 6 is also common. 1 is not common, 8 is also not common, 9 and 10 are also not common. So I have here 4 numbers which fall into the intersection, and that is why this is going to be the answer. So this is how you can do your set operations using the various operations and following the steps easily and clearly. Okay, so example 5 is very important question. This case usually asked in the examination, where you are given the Venn diagram and the regions inside the Venn diagram are marked with the Roman numerals 1, 2, 3 and 4, and you need to describe each of the set and the regions in the Venn diagram. So if I have to write A union B, for example, this is A, this is B, you know A, let me just write all the 3 sets once more, U, A and B. So A has 1 and 2, B has 2 and 3, and universal set being the biggest has all 4 parts. Okay, so A union B, that's what we need to take. That means I have to take whatever is common here, so that will be 1, 2 and 3. So these are the regions in the Venn diagram that will be selected for A union B. If you want to write the elements, then you may also write it in this manner. I have written it in a table so that I can compile more parts for you. So 1, 2 and 3. Okay, so that is the first row I have explained, and this contains the set of elements in both A or B or both. Okay, so it is union. Next is you take the union and take its complement. So what you are going to do, you will just take this part as U minus A union B. So from the set of universal having 4 elements, you subtract the A part. So you're just left with 1, which is 4. In a similar way, you can do the operation of intersection. And I hope you remember, for intersection, what we do is we take the common element. So let's do the C part also. A intersection B, very easy to see that from the Venn diagram. Will just have one element, that is 2. Then you have your intersection and the complement. So that means you remove the 2 and you have the remaining 3 from the universal set. So that is all about C and D. In a similar way, you could just write the last 2 parts also. Try them yourself without looking into the answer and see if you are getting the correct response. So very important, any part of this can come as a multiple choice question where you are given the Venn diagram and you need to write the regions or describe the set. Okay, so this is a very important question. Let's try it now. So in this question, you are asked to find the cardinality of each set. You are given 2 sets A and B inside the rectangle U representing the universal set. So it has a lot of elements. If you want, you can count and write the universal set also, but we are not asked for that till now. So we are just going to write and try first 39 and 40, where we are writing the cardinality of the two sets A and B. So let me first write the number of elements in set A. So you can go to the Venn diagram and you can highlight on it and count from there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means the cardinality will come out to be 10, but if you want to be double sure, you can write the elements also. So I'm going to write them one by one. First I'm going to write all the numbers and then I'm going to write the alphabets, but you may write it in any way, doesn't matter. So 1, then I'm writing the next 3, then 5, then 6, 8 and 11. So I've written them in ascending order. Now I'm going to write the alphabets. So letters A, B, C, and then I have Y. So let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So seems like I have covered everything. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, good enough. So we've written all the elements. So these are 10 elements in the set A, as you see in the Venn diagram. So the answer for the first part would be cardinality of A is 10. Easy. Let's try the B part now. So I'm taking blue ink here. Oh, that's not good enough. Let me choose a lighter shade. Yes. So B, now we are going to write this set. In a similar way, we will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So looks like one more element extra. So we'll put the elements here now. 1, 5, 6, 9, 12. Oh, I missed out on 10. 15, and then the alphabets or the letters, which are Z, D, W, B. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've covered everything, and that tells me the cardinality of B is 11. So it has 11 elements, as you saw. Let me highlight the two final answers. This is cardinality of A, this is cardinality of B, and this set you saw has 11 elements. Okay, so we are done with 39 and 40. Now before we move on to the other two parts, maybe I will do this one for you and you may try this yourself. We need to write the universal set, because here we are taking complements, and in order to get the complement we need to write our union, or you need to write your universal set nicely. So let me just write it over here on the top. So the universal set, you know, is the biggest set. So I'm going to write everything which is in A and B, and definitely the numbers which are outside. So first let us count so that we don't miss out. 1, 2, 3, 4, 5, 6, 7. So there are 7 outside. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So looks like there are 24. Let's write them so that we are sure that we are not missing anything. Now I'm not writing them in any particular fashion. I'm just randomly going to list them. So let me highlight here so that I don't miss. So I'm taking these elements first. 7, E, 14, O. Then I'm taking these which are outside. So 13, F, and U is your universal set. So be careful, don't write that one. Okay, so I'm done with the outside elements. Now I'm going to write the inside. So 8. Now I'm taking the red circle. 11, C, 3, A, Y, 1, 5, 6 and B. Now I'm moving to B, the blue circle. Z, 9, D, 10, 12, W and 15. So looks like we've covered everything. Let's now count and check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that means my cardinality of U is 23. And let's be double sure. Let's just count it from here also so that we are not missing any element. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Yes, so we are right. We've covered all the 23 elements. So now we are ready to answer for A complement, and then we are going to do the similar for B complement and finally take their intersection. So here we are now going to write A complement, which is U minus A. Now my universal set has 23 elements and my set A has 10 elements. So I know that my cardinality of A complement would be 23 minus 10, which is going to be 13. So it will have 13 elements. Let's try and write those 13 elements now. So from the whole universal set, this has already been written for you. I'm going to remove the specific. So I remove 1, I remove 3, I remove 5, 6, 8, 11, A, B, C, and I also remove Y. So whatever I'm left with are going to be in A complement. So let's write 7, E, 14, O, 13, F, Z, 9, D, 10, 12, W, and 50. And now you may count. It should come out to be 13. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Perfect. That means we are correct. So let's now proceed to B complement. And for B complement, just in a similar way, it is going to be your universal set minus B. So 23 minus 11. So that is going to be 12 elements. Okay, so let's write those 12 now. I'm going to write it in a similar way. So I'm going to remove from the universal set all these elements, and now I'm going to just write it looking at the Venn diagram. So I'm going to remove this whole set. I'm going to maybe highlight it with yellow only. I'm not going to write these elements because I'm removing B, and whatever is outside this blue circle is my B complement by default. So let me write all of them. 7, E, 14, 4. Then I'm writing from the red circle 8, 11, C, 3, A, Y, and then the remaining 2, 13 and F. So let me now count and check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like we are on the right track. So B complement cardinality has come out to be 12, which is what we want. Now these two sets have so many numbers in common, and that's what we need to write for writing the A complement intersection B complement. So let's see what is common. I'm going to use the red color. So here very well I can see these 4 are common. So I just put them together. Then 13 and F are also common. So I'm also going to put them together. Let's look at the remaining numbers. So Z is not there, 9 is not there, D is not there, 10 is also not common, neither 12 nor W nor 15. Look at these numbers also. 8 is not here, double check. 11 not there, C is also not there in set A, neither 3 nor A nor Y. That means only these highlighted parts are common. Let's write them now. 7, E, 14, 4. So these 4 I've taken together, and we're also having these 2. So 13 and F. And now we're in a position to just count and say the final answer. So the cardinality of A intersection A complement intersection B complement is going to be the number of elements in this set. So 1, 2, 3, 4, 5 and 6. So that's your final answer. This is how we have covered 3 parts. This one you will try yourself and let me know. I hope you have understood this method, and then similar way try question 49. Time to check your understanding. So this is a question that has the Venn diagram given to you and you need to write or describe the region, very similar to the last example we had done. Try this question yourself and let me know in the comment section if you want me to check your answer. So with that, we have come to the end of today's session. Please revise what we have covered today about the Venn diagram and how to solve problems. And we are going to be next covering the last topic of set theory. So see you in the next class and looking forward to meeting you all. Don't forget to like, share and subscribe to my channel and hit the bell icon to receive all notifications about my upcoming videos. This is me, Ms. Ruchika, signing off. Bye students.